Hello everyone, my name is Horace, and in this video we're going to be going through LeetCode number 560, subarray sum equals k. For this problem, we're given an array of integers nums and an integer k. We want to return the total number of subarrays whose sum equals to k. And a subarray is a contiguous non-empty sequence of elements within an array. So as always, let's go through an example so we can understand the problem more clearly. So we're given two examples, each of which have an array of integers nums and an integer k. So for the first example, we want to find subarrays in nums such that the sum of the subarray equals to the k value. If we take the first two elements, we'll get a subarray sum of 2. And if we take the last two elements, we'll also get a subarray sum of 2. Hence why the return value for this example is 2. Similarly, for the second example, we have to find subarrays in the array nums such that the subarray sums to the k value, in this case 3. So the two subarrays that sum to a value of 3 in nums are the first two elements again and the last element. Both of these subarrays sum to 3, and again we have a return value of 2 subarrays. So how can we go about finding each of the subarrays which sum to the k value? If we look at a brute force solution, we can first list out all of the possible subarrays in the nums array. Then we can simply find which of the subarrays sums to the k value. However, the brute force algorithm will have a worst case time complexity of big O of n cubed. That's because we have to first find each of these subarrays, which takes big O of n squared time, and then finding the sum of that will take big O n time. Well, we could possibly think about using a sliding window and try and increase and decrease the window based upon the elements that we have. However, if we look at the constraint that we're given in the problem, we can have negative values as the elements. This means that we don't actually know if we're increasing or decreasing, and hence why we can't actually use a sliding window for this problem. The next best thing to a sliding window is going to be a prefix map. If we understand what's happening in the brute force solution, we're simply seeing a lot of repeated work done. For example, if we want to calculate the subarray sum for the entire array, we're already calculating the subarray sums for the 1 and 2 elements prior to that. Is there any way that we can use that information and use it to calculate the sum for the entire array or any greater elements that follow the smaller elements? Well, we can use a prefix map to keep track of the prefixes that we see when we're finding the subarray sums. For example, if we know that the entire subarray sum is 3, and we know it has a prefix sum of 1, we can just remove it to get a k value of 2. So then we're going to have to keep track of two values, a total sum and a result value. The total sum value is going to keep track of the current sum as we're iterating through the nums array. And the result value is going to hold the value of the number of subarrays that have a sum equaling the k value. We can initialize both of them to be 0. So let's go through the first array in nums. If we start at the first number, we want to update the total sum and check if it's in the prefix map. So we simply add it to the total sum, and in this case it becomes 1. Then we want to check if the total sum value minus the k value, so in this case it's 2, if this is in the prefix map. And if it is, we can think of it as chopping off a part of the subarray, namely the prefix, to get a value equal to k. So 1 minus 2 is -1, and since there's nothing in the prefix map yet, then we can't actually chop off any value. So then we add the total sum value into the prefix map. So we simply say the prefix is 1 and the count is 1. Then we move to the second element in the array. Again, it's a 1, so we add it to the total sum value. We check if the total sum minus the k value, so in this case 2, is in the prefix map. Well, it seems like it's not, but actually it is. We also have to keep in mind of the edge case when k is equal to 0. If k is equal to 0, we can think of it as the empty subarray. And we can already see from the subarray that 1 plus 1 is already equal to 2, which is the k value. So we don't actually need to remove any of the prefixes. So really what we have is already in the prefix map before we start, we want to have a prefix of 0 with a count of 1. Since we can always remove the empty subarray from the current array that we're looking at. So we have that 2 minus 2 is equal to 0, and 0 is in the prefix map. So we take the count at 0 and add it to the result. Then we have a result of 1 thus far. Finally, we look at the entire array, which is the subarray of 3 elements. The total sum in this case is 3, since we have 1 plus 1 plus 1. And if we minus k, which is 2, then we get 1. And we can see that 1 is already in the prefix map. So we take the count and we add it to the result. So 1 plus 1 is 2. And since we're at the end of the nums array, that means we can return 2. As we have seen, that's the correct return value. So this algorithm is going to be running in a worst case of big O of n and have a space complexity of big O of n. The second example is very similar, so I suggest trying to fill out the prefix map before attempting to write the code. With that being said, we can go over to LeetCode and see how the code looks. Okay, we're on LeetCode and we can start writing the code for this algorithm. First, we can initialize the prefix map, and we already know that the 0 value is going to be initialized with a count of 1. Then we can initialize the total sum value and the result value. We want to iterate over the nums array, and the first step in the algorithm was to add the current number to the total sum. So we can just write total sum and increment it by the value of num. Then we want to check if the total sum minus the k value is in the prefix map. So if total sum minus k is in prefix map, then we want to increment the result based upon how many times that prefix has occurred. So result, and then we'll just get the value from prefix map as the total sum minus k. Then we simply want to add into the prefix map or update if it's already in the prefix map. So if total sum is already in the prefix map, then the prefix map total sum, we want to increment it by 1. Otherwise, we want to add it. So prefix map total sum is equal to 1. Then we can return the results, and this is the entirety of the code. So we can try and run it and see if it's accepted. So you can see that the code is accepted, and this is the optimal solution running in linear time and has a space complexity of big O of n in the worst case. With that being said, hopefully this video helped you and you learned something, and I'll see you soon.